Okay, so beginning our review for exam 3. Okay, so these questions are all pretty similar to type of questions that you should expect to see on your third exam. Make sure before you start doing these questions that you've printed out our formula sheet, right? That's in Blackboard. And you've also printed out the Z table and the T table. You're going to need those as you go through this worksheet or through these practice problems. Okay. Alright, so starting with Module 12, which is all about the standard normal distribution. We will expect to see some questions like this on the exam, where they basically say Z is a standard normal, and you need to calculate some probabilities. Alright, so this first question, drawing, I always like to draw these normal distribution questions out. 0 is in the center of the Z normal distribution, so negative 1.36 on this side. It says Z less than, okay, so that's back here. Now if I go to my table, the table tells me the less than area, the back area. So I should find the Z, for which I have negative 1.36. Negative 1.3, and then over to 6. This one right here. Okay, so you should pull out your Z table and make sure that you get the same thing. 0.0869. Alright, and then probability that Z is greater than, so in the center I have 0, this is greater than 0.13 is right there. Greater than would be the area back here. Okay. Now if my table only tells me the less than area, it only tells me the less than area, then I need to realize that the entire area is 1 and then subtract 1 from whatever value I find. Okay, so basically I'm going to say this is equal to 1 minus the probability that Z is less than 0.13, which is 1 minus, I look up in my table, 0.13, 0.5517, get out my calculator, 1 minus 0.5517, and I get 0.4483. Okay. So now finding between probability. Okay, so now Z is between 0.25 and 2.03. So it's between these two. Okay? So remember the way we find this is by first finding the probability that Z is less than 2.03. So this is equal to the probability that Z is less than 2.03. But that's too much, right? That's all of this area. So I need to then subtract off the probability that Z is less than 0.25. Okay? So I have to find both those values in my table, starting with 2.03, 2.03, okay? I get 0.9788, okay, 0.25, I get 0.5987, okay? Let's get out your calculator and subtract those two. I get 0.3801. Okay. So now, these were all problems where you're trying to find a probability given, trying to find a probability given the Z values. These ones are all trying to find Z values. Okay. So, given the probability. So they tell us the area, and we find the corresponding Z value. In this one, they gave us the Z value, and we had to find the area. Okay, so find the third quartile of the Z distribution. So third quartile, remember quartiles mean, third quartile, remember, is the 75th percentile. Remember, this is the same thing as saying 75th percentile. And percentiles mean the percentage that's less than. So 75th percentile means 75% of the population is less than whatever that value is. Okay, so the 75%, this area here is 0.75. So I have to find what's the corresponding z-value. Right? Since it's more than 50, I know it's going to be a positive value. So I go to my positive side table. Now I'm looking on the inside. I'm looking for 0.75. Alright, we're just getting close to it. Alright, so you see here 0.75 is between these two. It's between 0.67 and 0.68. Now which one is it closer to? This one is 0.014 away, and this one is 0.017 away. So when there's one of them that's closer, you choose the closer of the two. Okay, if they were exactly, your number you were looking for was exactly between them, then you would average the two values. Okay, so since this one is closer to 0.75, that's going to be our z-value. So 0.67. Okay, so that's the 75th percentile. Okay, find the z-values that separate the middle 60%. So this means there's 60% in the center here. We want to find those two cutoffs. Okay? So we have to do some thinking about this. Remember, this table only ever tells us the area behind a certain value, right? So what's the area behind this value here? I have to think about this. 60% is in the middle, so that means 40% is on each tail, or is on the tails, which means since this is symmetric, 20% will be here, and 20% will be there. Or 0.2, 0.6, 0.2. Right? Entire thing adds up to 1. And it's symmetric. Okay, so then the area behind this, from here backwards, is 0.8, right? So this is 0.8, and I need to find the z-value. So let's look for 0.8 inside the table. Okay, so here this is 0.7995, 0.8023. This one is closer. It's only 0.005 away. So the corresponding z-value is 0.84. Okay, since this is a symmetric distribution, this is going to be negative 0.84. You could do the same exercise though and look for see what's behind that 0.2, right? So I could look for 0.2 in the shaded. I could look on the inside and find the corresponding z-value, and I should get negative 0.84. Okay, so now let's see, given this, we want to find what z is. Alright, so we know that probability of z is greater than, so this area, it's going to be a small area though actually. So this area is 0.0668, right? So this tiny little bit that is greater than z is 0.0668. So remember, the table gives us the back area, so I need to find what's the area back here. Well, should be 1 minus 0.0668. Okay, so that is 0.9332. Alright, so now I need to find that z-value. So I know this area is 0.9332. So I look for it. There, there, right there actually. And the corresponding z-value is 1.50. Okay, so 1.50.